Welcome, ladies and gentlemen. Renewables are coming and a new battle of technologies arises. The reciprocating engine needs to defend the title won in the last battle against CCGT. Let me introduce the competitors. In the orange corner, we have the challenger, the fearless Aeroderivative.
Hey everyone, this is going to be easy.
And in the blue corner, we have the audacious Reciprocating Engine defending the title.
Hello, I'm very optimistic today about this battle. However, I know I'm facing a very strong competitor.
And by my side, as our guest, to comment on today's fight, the combined cycle gas turbine, king of baseload. CCGT, after being defeated in the last battle, you brought your prodigy, the Aeroderivative, to compete against Recip. Tell us your strategy to win this time.
Yeah, hello everybody. Glad to be here today. I do not need a strategy really here today. I only need to watch how the aeroderivative gas turbine beats the opponent. Go Aero!
Well, I wish you guys good luck. And now the referee will explain us the rules.
Hello everyone. In our last match, the opponents were worlds apart in skill. This round, we have two competitors who have trained to provide grid stability. We should have a good fight. There will be 3 rounds, 1 on flexibility, 1 on plant operation, and 1 on efficiency. Points will be scored in a simplified back and forth style fight manner. When relevant, each opponent represents a 200 megawatt facility. So, it's 11 engines for you, and that's 4 turbines for you. All right, round 1 is all about flexibility. Let's see how they start up for this fight.
Speaking of starting up, give me 5 minutes and I'll show you real power recip.
Not only I can match you at 5 minutes, but I can synchronize in 30 seconds producing power. How do you compare?
Well, it takes me 3.5 minutes to sync to the grid. However, I can ramp at 200% per minute.
I'm fast as well, ramping at 100% per minute. Even better, I can cycle on and offline multiple times per hour without having to run for a set period of time. I have heard that you need to run for at least 1 hour to avoid additional maintenance.
Technically, I can do it. However, common practices constrained by emissions, thermal stress, and market dynamics keep me at hourly intervals.
Cycling within 1 hour seems to be an issue for you. Do you also have limitations restarting after you stop?
If push comes to shove, I could. However, I still need 10 minutes to purge, but again, that's only in exceptional situations. I have no additional starting costs when cycling.
I can assure you that I have absolutely no starting cost. 0. Regardless how many cycles I perform in my lifetime. Do you have any restrictions on the number of cycles that you can do?
Well, I do have to admit that there is a 10,000 cycle limit, at which point I'll have to replace some key components. But really, how often are we going to reach these numbers in the real world?
We are getting into a more intermittent world, where all we do is cycling. We have seen in the United States around 1,200 cycles a year. So we will reach the 10,000 cycles during our lifetime. In your case, with 3 types of cycles, full, partial, and trip, you will get there faster than me. And as you said, this contributes to a major additional maintenance cost.
Ouch. Never thought I'd be facing this.
Indeed. As we have heard, intermittent resources are a crucial part of decarbonization. These 2 contestants exhibited exceptional start, stop, and restart characteristics. However, in the end, the 10,000 cycle limit for you is a limit compared to the engine.
Well, end of the first round. CCGT, what are your impressions after this round?
Yeah, it was actually pretty even. No clear advantage for any of the 2 in my mind. But I am still fully confident that the aeroderivative will win this battle. Just watch.
Let's see them.
Okay, Round 2 is all about plant operation. Here we will hear about water usage, gas pressures, and availability of the facilities. With summer around the corner, it's about to get hot.
You look a little thirsty. What is your water consumption?
Okay, well, for a 200 megawatt facility, I'll need about 200 gallons a minute. But how much water do you need?
Only a few gallons of water per week. Only for the facilities, not for my process. May I ask, what is your gas pressure requirement?
I need 700 psi, or about 50 bar. Why do you ask?
So finding a site for you may be challenging, unless, of course, you install a gas compressor, which reduces your output and efficiency. I only need 85 psi, allowing me to be placed virtually anywhere.
Okay. But I understand you need a lot more land than I do. Almost double the square footage per megawatt. So in most cases, that's going to lead to a higher capex.
You're correct to a certain extent.
Yeah, but you need a bigger site than I do, right? That's just a fact. But what's your typical unit availability? I bet I got you beat there. According to GAD's data, here the statistics in the United States point to the fact that mine is 93%.
From the same statistics, my availability is also 93%, so you do not beat me.
Really? Okay. But how about unit reliability? Mine's very high, 97%.
Mine is 97 too. How about your unit start reliability? Mine is 99%.
Mine's 99% too, so we're tied there. Look, I know I'm better than you are when it comes to maintenance costs. You require a lot of care. What's your typical variable O&M?
I'm just below $6 per megawatt hour, including urea.
Okay. Well, I'm below $5 a megawatt hour, including urea. And I bet I need fewer people to operate a plant than you do. My normal staffing is just about 5 people in a 200 megawatt facility.
In a balancing application, I do not require more than 5 people either.
Wow, okay, so this round had some ups and downs. Water usage and pressure requirements are kind of in the engine's favor, while availability and variable operation costs remain balanced between both fighters. Everyone in this fight is looking pretty fair for now.
Well, this was tight. CCGT, do you think today's battle could end in a dead heat?
No, I don't see that coming, but the aeroderivative will give the final punch to the recipe. Go, Aero.
Let's see then.
Round 3 will be the deciding factor. The opponents will be faced with 2 categories, heat rate and efficiency challenges. Fight!
Okay, you and I both know that my bread and butter is to run on high efficiency at steady state. My higher heating value heat rate, 9,400 BTU per kilowatt hour, best in class. What's your puny engine's heat rate?
My heat rate is 8,100 BTU per kilowatt hour. I'm in combined cycle territory in an open cycle. I need much less fuel than you, saving quite a bit of money.
Really? Okay, but what about part load? What's your heat rate at 50%?
8,900. Can you keep up with your 9,400?
I cannot. At 50% load, I'll be at 10,700.
Wait a minute. You said you have high efficiency?
I did.
My minimum stable load is 10%. Can you do the same?
Nope. I can only go down to 40 or 50% minimum, or I'll be outside of my air permit.
Aha. I can operate a 200 megawatt plant with 11 units on 8,000 heat rate at almost any load between 2 and 200 megawatts. What is your planned load range?
Well, with a minimum stable load of 50%, I can only operate a unit at above 25 megawatts due to air permit restrictions. So I can operate a 4-unit, 200 megawatt plant between 25 and 200 megawatts. And the heat rate will vary between 9,400 and 10,700.
One more thing. I'm able to maintain the same output at 1 mile above sea level with temperatures at 100 degrees Fahrenheit. What is your output in those conditions?
Oh, well, I would need to derate my output by about 40%, unless I add inlet air cooling to improve the situation. But again, these are extreme conditions and not really relevant to this conversation.
Maybe, but you will have lower output on warm days when energy is needed the most. It looks like it wasn't so easy after all.
Wow, okay, so what a fight we are at the end, watching two champions duke it out on stage for the title. Looking back at the first 2 rounds you competed in, flexibility and plant operation were very evenly matched, if you don't consider the 10K cycle limitation that you had, Aero. However, the last round, the reciprocating engine really made up ground when it came to efficiencies, scoring in almost every category presented. Thank you both for a fair fight, but I do have to declare a winner here. And in this case, it is going to be the reciprocating engine, due to extreme efficiency and ability to cycle. Congratulations.